This is chapters 1.5 to 1.7, pre-assessment. At this stage, you should be fine-tuning your work. You should have your notes in front of you, and you should have your note cards with the key ideas. So chapter 1.5, we have variables on both sides. We know we have to move the variables first, so I'm going to move them to the right. I need to get rid of the negative 3x, so I will add 3x to both sides. That leaves me with 12 equals negative 3x. We're going to divide by negative 3, divide by negative 3, and we get negative 4 equals x. If we're going to check our solutions, we write the original problem, and then we plug in negative 4 for my x. And now we'll do orders of operation. This is negative 3 times negative 4, which is positive 12. Negative 6 times negative 4 is positive 24. 12 plus 12 is 24. Equals 24. Since it does, that means this solution is correct. We're not going to check. We'll just show the checking for the first one, but for time purposes, we're going to just solve for the variable. So we have variables on both sides. We have constants on both sides. Always remember, move the variable first in these situations. So I'm going to subtract 3a from both sides. That gives me 3a minus 4 equals 5. Now I'm going to move the constants to the other side. Whoa, not 5, 4. Plus 4, plus 4. 3a equals 9. And then we'll divide by 3, divide by 3. A equals 3. We have variables on both sides. We have constants on both sides. We're going to move the variables. I'm going to, well, let's do it in green. Let's do this. I'm going to move. I'll add 5z to both sides because negative 5z and positive 5z cancel, leaving you with 7. And then you have 17 plus 5z. And we are going to combine these like terms. You get 17 plus 10z. And now I'm going to move the constant to the other side. So we moved the variable. Now we're moving the constant. We have 7 and negative 17 gives me negative 10 equals 10z. Now we'll divide by 10. Divide by 10. Negative 1 equals z. We have variables, so let's move this 3k. We have to subtract 3k to get rid of the positive 3k. These cancel. Leaves you with 45 equals, that's 5k plus 25. Now we're going to move the constant to the other side. 20 equals 5k. Divide by 5, divide by 5. And 4 equals k. Always try to simplify, not try, always simplify before moving. So we can combine these because they're on the same side of the equal sign. We can't combine it with this because it's on a different side of the equal sign. So we're just simplifying each of the sides of the equation. 2q and q makes 3q minus 2. And now this looks like problems 1 through 4. We've got variables on both sides. I'm going to move the variable to one of the sides, giving me 2q plus 6 equals negative 2. And now we'll get rid of that constant. Still trying to isolate q. We have to consolidate the q's, then we have to isolate the q's. Minus 8, we'll divide by 2, and q equals negative 4. Again, we see that we have like terms on the same side of the equal sign. 8 minus 4x equals 16 minus 8x. I'm going to move this 8x over to this side. 8 plus 4x equals 16. Let's subtract the 8. 4x equals 8. Divide by 4, divide by 4. X equals 2. Now we have to simplify, but this time we have to simplify by distributing. So we're going to distribute those terms. 2 times 4b is 8b. 2 times negative 6 is negative 12. 4 times 3b is 12b. 4 times negative 7 is negative 28. We're going to move the variables first. Don't forget that negative there in front of the 12. Negative 12 equals 4b minus 28. Let's add 28. Add 28. And we have negative 12 and positive 28, which gives me positive 16 equals 4b. Divide by 4, divide by 4. 4 equals b. We're going to distribute, and we'll distribute. 4 goes into 48 12 times. 12 times 3 is 36. I would not multiply 3 times 48 and then divide. I'd cross cancel. And then 3/4 times negative 16x. 4 goes into 16 4 times, so that's negative 4. And I got a bug on my thing. Here you go. 4 goes into negative 16x, 4 negative 4 times, so you get negative 12x equals 4 times 4 is 16. 4 times 2x is 8x. I'm going to move this negative 12x by adding 12x. And that gives me 36 on the left side equals 16 plus 20x. Now I'll subtract those 16s. And that gives me 20 equals 20x. Divide by 20, divide by 20. And 1 equals x. We distribute again. Decimals are just as easy as fractions. Decimals don't scare me. 6 times 5 is 30, plus the 1 decimal place is 3r. 6 times negative 4 is negative 24. But I have the 1 decimal place, so it's 2.4. Plus r equals 21 minus 9r. Now I have like terms on the same side. I'm not moving things yet. I have to simplify first. So 3r and positive r gives me 4r minus 2.4 equals 21 minus 9r. That's an r. Looks like an n, but it's an r. Let's move the variables. I'm going to add 9r, which simplifies to 13r minus 2.4 equals 21. Let's add the 2.4, add the 2.4. 13r equals, what's that, 23.4? All right, we're going to check, make sure that's 3. Yes, that's 2.4. That's okay. So we're going to divide by 13. Divide by 13. And I'm assuming that's going to go in. We're going to use our calculator, 23.4. Whoa. 23.4 divided by 13. 1.8. 1.8. And it's positive 1.8. Nice? Good. Okay. Excellent. Ooh, this is a good one. We can't combine those. Those are unlike n. This is -8 distributing into this, and this is -6 distributing into that. So we get 3x, and then -8 times 2x is -16x, and -8 times 3 is -24, equals -6 times 2x is -12x, and -6 times 5 is -30. Like terms, yep, on the same side. Let's simplify. That's -13x minus 24 equals -12x minus 30. Let's move the 13x this way. -24 equals x minus 30. Let's add 30 to both sides. And we get 6 equals x. Didn't have to do any more work. We have distribution. 16f plus 24 equals 16f plus 24. Yes, some of you already see the answer. We're going to move the variables first, subtracting 16f, leaving us with 24 equals 24. We notice our variables canceled. And we got a true statement. When your variables cancel and you get a true statement, the solution is infinitely many solutions. Not true. True is not the answer. Infinitely many solutions is the answer. Please give me only one answer. The alternate answers could be identity. And that's the identity property is what they're talking about. And then the other solution could be all real numbers. Those are acceptable alternative solutions. All right, let's distribute. Let's distribute 24s plus 72 equals 24s minus, what's that going to be? That's 8 times 12 is 94 plus 16. 2, 3, 112. I think that's correct. Let's move the constants, or excuse me, let's move the variables. Hello. We're going to move the variables, and you get 72 equals -112. Negative, write the proper answer. That is a false statement. So the answer is going to be no solution. And notice variables canceled. And you got a false statement. The answer is going to be no solution. Let's distribute. 2/3, 3 goes into 6 2 times. 2 times 2j is going to be 4j. 2/3 times 9, 3 goes into 9 3 times plus 6 equals 3j plus 7. Let's move the variables. That leaves you with j plus 6 equals 7. Let's move the constants. J equals 1. Oh, this is an interesting one. So let's get rid of that number for the time being. Let's This is good. Now we can find a common denominator, but the more efficient thing is to get rid of all the denominators. So our denominator is 5, 2, and 10. And the common denominator would be 10. So you're going to multiply everything by 10. And 5 is in the denominator, 10's in the numerator. So 5 goes into 10 2 times, and then multiply by your c, which is 2c. 2 goes into 10 5 times your c is 5c. And 10 goes into 10, leaving you with 7c. Oh, look at this mean one. You're a mean one, Mr. Grinch. Bum, 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 bum. You're really doot, 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 doot. So you get 2c plus 5c equals 7c, and then a lot of students would divide by 7. No, we're not trying to get we got to consolidate our constants. We have to move our variables to the same side, so you subtract 7c, leaving with 0 equals 0. That is a trick question. It is the variables canceled, and this is a true statement. So it is infinitely many solutions. That is such a good problem. This is such a good one. Distributing. We get 25 times 8. That would be 4. Right? 25 times 8 is 40. 40? No. 20. $2. Hello. 8 quarters is $2, so that's 20. And 2.5 times 2 is 5. Sorry, there's a 20x. Mr. Mac is so preoccupied and overwhelmed with his multiplication. And that's 5 equals 20x minus 4. Move the variables. 5 equals -4. That's a false statement. That's false. So that is no solution. Distributing. Half of 10 is 5. Half of 2n is 6n. A third of 15 is 5n. A third of 15 is 5. Let's move that variable over that way. And we get 5 equals n. Sorry, I'm rushing. I get 5 plus n equals 5. Let's minus the 5 now. N equals 0. You can get n equals 0. It is not no solution. N is a solution, or 0 is a solution. All right, now we got absolute values. Always remember to isolate the absolute value. It is isolated. So once it's isolated, we can write two statements. We can have y plus 2 can equal 8, or y plus 2 can equal -8. Because if this equaled -8, if this was equal to -8, it would produce an absolute value of 8. So that's why we write that statement. That's why we say y plus 2 can equal +8, or y plus 2 can equal -8. Let's subtract 2. Y equals 6. Let's subtract 2. Y equals -10. Those are my two solutions. We write them in solution sets, and we're going to write them in numerical order. Always remember, answers, aka solution, must be in numerical order. Inside of your solution sets. All right, we've isolated. So 3x plus 12 equals 0. And we don't have to write this because this doesn't have the other side. It doesn't have the other distance. So we're actually only going to have one solution to this. It's not often, but it's only when its distance is 0. And then we get 3x equals negative 12. We'll divide by 3, and x equals negative 4. Good. Nice and easy. Very unique, interesting one. All right, here we have to remember to isolate the absolute value of ours first. We have to isolate the absolute value. We have to get it by itself before we look at its distance. So we're going to subtract 2 from both sides. We get the absolute value of 6 minus 5v equals negative 1. And at this point, we should notice the red flag. Red flag. No absolute value can equal a negative distance, can equal a negative number. And it can't equal a negative number because no distance, this will produce a distance. No distance will ever equal a negative number. So this answer is no solution. Let's isolate. We have to isolate by dividing by negative 4. Divide by negative 4. We get the absolute value of 7 minus 6k equals negative 7 halves. We're going to simplify that, that fraction. And we again have an absolute value. We have an absolute value equaling a negative number. So that answer again is no solution. Back to back, no solutions. This is not isolated. We're going to divide by 2. The absolute value of 0.2g plus 8 equals 5. That's okay. So this distance must equal 5. So what two numbers? 0.2g plus 8. It can equal 5. This equaled 5. It would produce an absolute value of 5. And if 0.2g plus 8 equaled negative 5, that would also produce an absolute value of 5. Now we're going to solve. Subtract 8. 0.2g equals negative 3. We're going to divide by 0.2, 0.2, and we get g equals, now here's one where we'll show the simplification. We'll do it in blue, negative 3 over 0.2. I'm going to move that decimal point one place, and I'll move it here, which gives me negative 30 over 2, which simplifies to negative 15. So my answer is going to be negative 15. That's one of my solutions. We're going to subtract 8, leaves us with 0.2g equals negative 13. We'll divide by 0.2, divide by 0.2, and g equals, well, now we have 0.2 divided into 13, so that little scratch work, 13 over 0.2. We'll move that decimal point, move the decimal point, creates negative 130 over 2, which is going to be negative 65. So my answer is going to be negative 65. So if I'm going to write it in numerical order, I'm going to have negative 65, comma, negative 15 would be my two solutions. Let's isolate. Minus 10, 3 times the absolute value of 2x plus 5 equals 27. Let's divide by 3. The absolute value of 2x plus 5 equals 9. I've isolated my absolute value. It equals a positive distance. So I'm going to write my two statements. 2x plus 5 can equal 9, and 2x plus 5 can equal negative 9. Minus 5, 2x equals 4. Divide by 2, divide by 2. X equals 2. Minus 5, 2x equals negative 14. Divide by 2, divide by 2. X can equal negative 7. Those are my two solutions. Negative 7, comma 2. All right, last section. Now we got to isolate for a variable amongst other variables. It says y minus 2x equals 15. I want to isolate for y. It's being subtracted by 2x. The inverse of subtracting 2x is adding 2x, giving you y equals 2x plus 15. These are unlike terms, so I can't combine them. And I'm always going to write variable before the constant. We'll see how many people remember that. We're isolating for y, so I got to get rid of this 3x. That's a positive 3x. A negative 3x will get rid of it. When I cancel that, I'm left with a negative y equals negative 3x minus 4. I'm solving for y. Solve for y. That's a positive y. This is a negative y. So I can do a couple things. I can divide by negative 1. If I divide by negative 1, I have to divide everything, leaving me with y equals 3x plus 4. And that would be the answer. The other thing I could have done is multiplied by negative 1 and multiplying everything by negative 1. We're isolating for y. I got to get rid of this 4x. Let's subtract 4x, giving me 2y equals negative 4x plus 8. Let's divide by 2, divide by 2, divide by 2. Y equals negative 2x plus 4. These are nice and easy. Okay, I'm isolating for y. I got to remember which variable I'm isolating for. I'm going to minus this 8. I'm going to match it with a like term on that left side. 5x minus 10 equals 5y. Dividing by 5, divide everything by 5. X minus 2 equals y. I'm isolating for y. I'm going to subtract 7. Again, I'm going to match it with its like term. 3x minus 6 equals negative 4y. I didn't drop off that negative. I'm also going to divide by that negative 4. Gives me negative 3/4 x. This is going to be positive, and I'm going to reduce it. That's 3/2 equals y. You got to simplify those fractions. You can't leave it as 6 and 4. Definitely not negative. Isolating for y, let's subtract the 8. I'm going to match it up. Minus 1/3 y equals 6x minus 5. Now this is a fraction that is multiplying. The inverse of multiplying by negative 1/3 is definitely dividing by negative 1/3, but I don't want to do all that yucky work. The other inverse of multiplication is multiplying by the reciprocal, which is negative 3. When I multiply one side, I have to multiply everything on that. So y equals negative 3 times 6x is negative 18x. Negative 3 times negative 5 is positive 15. Good problem right there. You got that right. Good for you. Now we're solving for x. These are on the same side, so I can simplify first. Gives me 6x, and now we're going to make it real nice and easy. Divide by 6. Y over 6 equals x. We're simplifying for x. Let's get rid of that negative 2r, and we're going to match it up with a like term. 4g minus r, because positive r and negative 2r, equals negative 2x. Now we're going to divide by negative 2. Divide each by negative 2. That gives me negative 2g. This gives me positive r over 2 equals x. I like that answer. You could have 1/2 r. I don't mind that. We're solving for x, so we got to get rid of everything. Let's move the z's first. Let's move that z over, which gives me 4z plus 8 equals 12 plus 3x. Now let's move that constant minus 12. We're going to match it up. 4z minus 4 equals 3x. Let's divide by 3. And this one I'm going to divide it all by 3 because there's no like factor. So we could just write that. That's acceptable. If you wrote 4/3 z minus 4/3, that would be okay also, but that's the more efficient way. All right, here we are. We have this problem where we can't combine them. They're not like terms. But I need to consolidate my x's. So the technique is you must use factoring. So we're going to factor out a common term that's x is multiplying both of these terms. So we're going to factor out an x. If we take an x from 3x, it's 3, because factoring is a form of division. And if we factor that out, we get plus 9z. Now it's multiplying. We're trying to isolate x. It's being multiplied, so the inverse of multiplying by this quantity is dividing by this quantity. Divide by 3 plus 9z. We get q over, and I'm going to write 9z plus 3 equals x. I'm going to write it with my variable before my constant. How much time do I got? Oh, I got 8 minutes. Hopefully I can get through these. All right. Again, before I do that, I'm going to minus the 4 over there. I'm going to move it first. I'm going to write r minus 4 equals 7x minus sx. And I'm going to factor out the x. So I can take that x out, and it becomes 7 minus s equals r minus 4. It feels like we've done this problem before. 7 minus s, 7 minus s. Yeah, it does, doesn't it? R minus 4, and then I'm going to write my variable before my constant. I feel like that was in the Friday problems. Don't know. Let's move. Ooh, I already forgot what we're solving for. We're solving for x. So important. All right, so let's well, let's move the x. Let's move. I got ants all over my desk. Let's move this. We'll move the 4x over to the x, because we always want to move variables first. Y equals 6x minus 6. Now let's get rid of the constant. We get y plus 6 equals 6x. Let's divide by 6. I'm going to divide each piece by 6. That gives me 1/6 y plus 1 equals x. I did that just because they're like factors. Oh! Just when I said that there was 8 minutes left before the next class came, boom, we are done. All right. Hopefully this worked out for you. Don't forget to go look at notes. Don't forget to look at extra practice videos. Don't forget to look at the Friday problems. Practice. Good luck. We'll see you at the assessment.